Wearable technology has become commonplace in our lives, telling us our heart rate and sleep patterns, for example. Can it soon be helping to predict the onset of heat stroke in soldiers, workers, and athletes? In today's episode, we'll explore a study that looks at whether core temperature or changes in gait and balance can predict heat stroke after the fact in a group of soldiers performing military training. Do they work well as predictors individually, and might they work better when combined? Exertional heat stress, or EHS, is a common risk during exercise in the heat for soldiers, athletes, and workers. By the time it happens, the consequences and odds for survival can be dire. Beyond the risk to the individual, an incapacitated soldier also means risks for their comrades in caring for them and removing more than one soldier from operations. The best clinical treatment for EHS is rapid cooling, ideally from immersion into cold water. Again, for soldiers, this can be challenging in a mobile battlefield, highlighting again the need for prevention. The two symptoms common to EHS are high body temperatures and also loss of coordination due to the changes in the central nervous system. So is it possible to predict EHS onset from measuring these two variables? This was the aim of a new study from the U.S. military, testing over 1,800 soldiers performing over 3,400 individual physical exercises, ranging from timed runs to marches with full packs. Over the years, this research group has developed an algorithm to predict core temperature from heart rate, which we'll call EC temp. The soldiers also wore an accelerometer that recorded their movement and balance in 3 dimensions, and the group developed a measure of gait instability based on the magnitude of wobble and also the changes from normal gait. They focused on the 6 actual cases of EHS and looked at whether either EC temp or gait were good predictors, along with a measure of EHS risk that combined EC temp and gait. On the left, we have the EC temp core temperature profile of one of the EHS cases in the dark black line, along with all the other EC temp values from other soldiers performing the same exercise. We can see that while EC temp was at the high end of all the values, it wasn't necessarily the highest, and there was nothing particularly striking about this or the other 5 EHS temperature profiles. On the right, we see a typical example of both low and high gait dispersion values. It's pretty evident that there is much more variability in wobble in the high gait example. Overall, both EC temp and gait by itself were not strong predictors of EHS, but predictive strength was much better with a combined measure of EHS risk. We don't want to just predict EHS when it happens, but ideally as far ahead of EHS as possible. We want to catch every episode of EHS before it happens, but at the same time, we want as low a risk for false positives as we can. That is, we don't want to say someone will get EHS when in fact they won't. How much of a useful time window might EHS risk give us? In this graph, we see how many false positives we get when we extend a time window from 0 through to 300 seconds before the actual EHS. With EHS risk, there is much lower risk for false positives than with just gait alone, at about 6% up to a time window of 210 seconds. Keep in mind that this study is predicting EHS after the fact from analyzing collected data. The next important advance will be analyzing that data in real time, so that we can see who is at risk for EHS and take preventative measures before it actually happens out in the field. For example, these wearables might be able to process the data in real time and either warn that individual or a leader, coach, or medical staff. This would ultimately hugely improve health and safety for soldiers, workers, and athletes. Hopefully this video doesn't knock you off balance. I'm Professor Stephen Chung, and I run the Environmental Ergonomics Lab in the Department of Kinesiology at Brock University. We post new videos on different topics in environmental physiology every Wednesday. Thanks for watching. We'll see you next time.